Okay, in today's class we are going to see translations, or we can say syntax directed translations. So as I just mentioned, this topic is related to semantic analysis. Semantic analysis is the third phase of the compiler design process. So if we recall the syntax analysis process, in syntax analysis we'll try to find out whether the source program is written according to the structured rules of the long ways or not, right? So all the programs that are structurally correct may not be may not be meaningful. Okay, it is something like, say, int x comma say some user defined data type of y, right? So even though it is syntactically correct, like if you write int x comma some user defined data type class y followed by semicolon, though it is syntactically correct, but it is semantically wrong. We cannot assign a user defined data object to a built-in object or a built-in variable, right? So that kind of assignment is illegal. It's not permitted in the long ways, right? So though it is syntactically correct, sometimes those those statements may be semantically wrong, or they have no meaning with respect to the, they're not in with respect to the language under consideration. Okay, so that is what we call semantic analysis. Even though it is lexically correct, all the terms in the sentence are lexically correct and the syntactically correct, they may be semantically wrong. Right? So those things that we'll check in this particular semantic analysis phase, right? So semantic analyzer is the program, the module which will check for semantic errors. Okay, one example for semantic error is this one, type checking, type compatibility errors. The other possible semantic errors are like in some languages the variables must be declared before their use. Like in C, first you have to declare all the variables, then only you can use them in the subsequent statements. Okay, if a variable is used without its declaration, then it leads to an error. It's a semantic error. It's an undefined name, no? Undefined name, right? So that is also an example for semantic error. So I will tell you one more example. Like if you recall the function signatures or the function prototype, usually functions will receive some parameters, no? Some number of parameters, list of parameters enclosed in bases, no? So this list of parameters must, when you call that function, when you invoke that function, the actual parameters that you pass during the invocation must match with the formal parameters, their types and the number as well, and the order also. Okay, so suppose while defining the function you have given two parameters, int x and float y, right? But while invoking you are giving, say, float value first, then followed by the int value. That is also a considered as a semantic error. Semantic error, right? Somebody is still waiting in the lobby. Okay, right? Another example is multiple declarations of the same name, right? In some programming languages it is allowed. It is language specific. In some programming languages it is allowed. Like in C, in C++ it is allowed, but in C it is not allowed. Okay, so in C++ name overloading is there, no function name overloading, so it is allowed. But in C you cannot have the multiple declarations of the same name. Okay, you cannot declare a variable more than once. Okay, that is also leads to semantic error, right? So what I mean to say here is there is no specific way, unlike this lexical analysis and syntax analysis. In lexical analysis, we have a way to specify the lexemes or the patterns, okay, by using regular expressions or the regular long ways. In syntax analysis, we have a way to specify the syntax of programming languages, okay. So we did by means of CFG, context-free grammars, but there is no specific way, okay, to specify all the semantic constructs of programming languages, okay. The reason being the semantics widely varies from language to language. They are widely varies from language to language. As I told you earlier, in some names multiple declarations of the same name is allowed, but in some programming languages multiple declaration of the same name are treated as an error, okay. So that is a typical example, right? So in some programming languages, data types are they're pre-declared, I mean the variables are pre-declared. In some programming languages they're dynamically declared, okay. Static typing and dynamic typing, the two terms used respectively uh, to denote these the languages which are pre-bind to types, to their data types are said to be static type, and those are bind only during the dynamic or the during the program execution are said to be dynamic typing languages, okay. So if it is a dynamic typing language, I mean we cannot check, like if you want to check x equals to y, a statement like x equals to y, if an x and y are dynamically allocated or dynamically I mean their scope is dynamic typing, then it